Hey guys, today we're going to solve exponential equations, but specifically with a common base. So these are actually on the easier side. There's only 3 steps to them. So you're going to use properties of exponents to simplify each side of the equation. So properties of exponents just means if you're multiplying, you would add the exponents. If you're dividing, you subtract, all those properties. Step 2, this is something we haven't talked about yet, but it's really simple. Use the one-to-one property, which states that if b to the x power is equal to b to the y power, so any base is equal to another same base, so it has to be the same base, b, then their exponents are also the same. But that's important, it has to be the same base. And then after that, you could just solve the resulting equation. So for today, everything is going to have the same base. So we don't have to worry about this property here. Everything's going to be the same base. So take, for instance, example number 1. 3 to the 2x minus 9 power is equal to 3 to the 7. So since they have the same base, we can just ignore the base completely and only look at the exponents. 2x minus 9 is equal to 7, and then just solve from there. So this is a really simple linear equation. We would add 9 to both sides. Then I have 2x equals 16, divide by 2. So now we're left with x is equal to 8. Okay, let's look at the next one. So we have the natural base e. So e raised up to the 4w minus 1 power is equal to e raised up to the 5 minus 2w power. But same deal, they have the same base. They're both e. So we only really need to worry about the exponents. So 4w minus 1 is equal to 5 minus 2w. Let's make it to where the w's are only on one side, so let's add 2w. So that's 6w minus 1 is equal to 5. Add our 1 to both sides. 6w equals 6. Divide by the 6. And we're left with w is equal to 1. Okay, so those first two were really simple examples. So now we're going to go one step harder. Let's look at number 3. So 5 to the c minus 1 power times 5 to the 3c plus 2 power is equal to 5 to the 7c plus 16. So this is what makes it harder, that there's two things on one side of the equal sign. So this is step 1 in the steps from above. You're going to combine these using the properties of exponents. So just as a side note, hopefully we all remember this rule. When you have x to the a power times x to the b power, when you combine them, you add up those exponents, a plus b. So we are going to do the same thing, only of course our exponents are a little bit harder than that. We're going to have c minus 1 plus 3c plus 2. So this expression here could be rewritten as 5 to the 4c plus 1 power. And then the other side, it's the only thing, so it's going to get to stay the same. But you see what I did there? C plus 3c is 4c, and then negative 1 plus 2 is positive 1. So now that there's only one thing on each side of the equal sign, now we only need to worry about the exponent. So now I can do the whole 4c plus 1 is equal to 7c plus 16, and we'll solve from here. Let's make it to where there's c's only on one side, so I'm going to subtract 4. 1 equals 3c plus 16. Let's subtract 16. So negative 15 equals 3c. Last, let's divide by our 3. Oops, running out of space, so I'm going to write it here on the side. negative 5 is equal to C. Okay, the next one is going to be really similar to that. So if you look, on each side of the equal sign, I have two things. So 4p minus 7 times 4, 2p plus 1. So we are going to have to combine those using the product property of exponents. But same thing for the other side. I have this 4, and they're being multiplied. So we're going to combine those using the product property. Okay, so on this side, it'd be 4. We're going to add those up. So p plus 2p gives me 3p. Then negative 7 plus 1 would be minus 6. Okay, let's combine everything on the other side. 3p plus 5p equals 8p. And then I'll just have the minus 36. So now that it's only one term on each side, we only need to concern ourselves with the exponents. So I will have 3p minus 6 is equal to 8p minus 36. Let's fix it to where there's p's only on one side. So let's subtract the 3p. Negative 6 equals 5p minus 36. Okay, now let's add 36 to both sides. That gives us 30 equals 5p. And last step, divide by the 5. Again, I'm running out of space, so I'm going to write it here on the side. 6 equals p. Okay, so these second two, the only difference here was that you had to simplify each side of the equal sign before you could solve. But otherwise, you're really just looking at the exponents when you're solving here. Okay, two more examples, and these are even one step harder, but still on the easy side. Okay, so the difference here, so let's look at number 5. Not only are we going to have to simplify each side, so you see that multiplication, so we are going to have to combine, but when you look at the exponents, I have k squared. So this is going to give me a quadratic equation. Okay, but first things first, let's combine. So here, 8. We need to add up all these exponents. There is only one that's squared, so k squared. That's the only one. But then I have plus k and plus, oops, that should have been a k. So plus k and plus 2k, so that would be plus 3k, and then minus 9 is equal to, okay, other side. We're just going to add those two exponents up. But since one has a k and one doesn't, we can't combine them. We're just going to put them next to each other. So 4k plus 11. Now, since they both have the same base of 8, we only need to concern ourselves with the exponent part. So k squared plus 3k minus 9 is equal to 4k plus 11. So this is a quadratic because of that x squared. When you're solving quadratics, it needs to equal 0. Like there cannot be anything here. So let's move both of those things. So minus 4k and minus 11. So same thing here, minus 4k, minus 11. And I went ahead and put it underneath its common, or its like term. So k squared. 3 minus 4 would be negative 1, so minus k. And negative 9 minus 11 would be negative 20. And now that all equals 0. Okay, so now I have a quadratic that equals 0, so this will be easier to solve. There's different ways. You can use quadratic formula, so that negative b plus or minus square root, that whole thing. You can factor, which is what I'm going to do, because I think factoring is probably the easiest thing to do here. So in order to factor this, I am looking for two numbers that when I multiply gives me negative 20, but when I add gives me negative 1. And I'm getting these from right here. This is B, this is C, this is A. Okay, so factors of negative 20 would be 1 and negative 20, 2 and negative 10, 4 and negative 5. I think that's going to be it for us. So looking at this list, I think it's obvious that it's going to be that last one that gives me negative 1. So when I factor this, I'll have k plus 4, k minus 5, and that equals 0. So in order to solve, we're going to set each one equal to 0. Okay, to solve the first one, it's one step, minus 4 from both sides, so k equals negative 4. Solve the next one, add 5 to both sides, so we get k equals 5. So we get two answers here, so we're going to write this as a set. We always go smallest to biggest, so it'd be negative 4, comma 5. We happen to already do it in the correct order. Okay, so the only reason why I say this one is harder than the other one is because instead of being a linear equation, it's quadratic. But quadratics are Algebra 1 skills, so I believe everybody should be okay with this one. But just for practice, let's do one more. So common base e, but just like the other one, I can tell right away that this is going to be a quadratic equation because of that squared. So first things first, let's simplify each side. So let's combine these two things by adding. So this would be e to the m squared minus m plus 9 power. So all I did was I got this exponent, combined it with this exponent, and every single one was a different term. Equals e. Well, I'm going to do the same thing to this side. 2m plus 3m gives me 5m. And then I still need to have that plus 1. Okay, now that they have the same base, we can just concern ourselves only with the exponents. So m squared minus m plus 9 is equal to 5m plus 1. We need it to equal 0. So let's subtract these two terms from their respective like terms over here, which will leave us with m squared minus 6m plus 8 is equal to 0. So just like before, the easiest way to solve this is going to be to factor. So this time around, I'm looking for two numbers that will multiply to positive 8, but will add up to negative 6. Okay, so factors of 8 are 1 times 8, 2 times 4, and that's really it. So when you add this up, 1 plus 8 is 9, 2 plus 4 is 6, which is the correct number, but I needed it to be negative. So what we're going to have to do is negative 2 times negative 4. That still gives us positive 8 because negative times negative, but when we add it up gives our negative 6. So we're using those two numbers. M minus 2, M minus 4 equals 0. Okay, so to solve, let's set each one equal to 0. They're each only one step each. We're going to add 2 to both sides, so m equals positive 2. And on this one, we're going to add 4 to both sides, so m equals 4. So in this case, it could be two of those numbers. So we're going to write our answer as a set, 2, 4. Okay, guys, and that is solving exponential equations by hand. As soon as you're done writing this, you can glue this into your notebook. This is part of your notes. And that's it. Have a good day.